So we're gonna have y equals, and it says our a is 0.193 x squared. Okay, and then our b 3.34, and that'll round up to 1. So 3.341x plus 3.341x. C is the last number, 70.421. So plus 70.421. So this is part A. Okay. Part B says, using the regression equation found, determine in what year sales reach their maximum. All right, so we want the highest number of sales. And so what we're going to do is put this equation that we just found, we're going to put in y equals, and we're going to look at our table, and we're going to see where does it hit the highest amount of sales. All right, so go to y equals. I'm sorry, this should have been negative 0.913. I'm sorry, I missed that. So negative 0.193x squared. Okay, so negative 0.193x squared plus 3.341 x plus 70.421. Okay, so you're going to put that whole equation in y equals. Go to your table, so press second graph. So you're going to scroll through that table and find where the biggest cell is. Where's your maximum? Okay, so you can see it's getting bigger and bigger as you go down. So keep going down. You want to find the biggest sale. So look at your y values. Where's your biggest sale? Okay, do y'all see it? Like, it goes up like 84.834, 85.349. It's still going up, 85.478. And then after that, it goes back down to 85.221. Okay, so our biggest sale would be when x is 9. That's when it hits its maximum. Okay, so we're talking about 9 years, and it's 9 years from, if you look back at the problem on your paper, 9 years from 1980. Okay, so on part B, it would be the year 1989. Okay, part C. Use the regression equation to estimate the total sales of TV antennas for 2008. Round the answer to the nearest tenth of a million. Okay, so 2008, you have to ask yourself, okay, how many years is that from 1980? So, in part C, we have 2008 minus 1980. Okay, so what is that, 28 years? 28 years later. So you're going to take your equation, and whenever you see an x is the same thing as t in this problem, you're going to plug in 28. Okay, so let's do that. Our equation is negative 0.193 and then x squared, so 28 squared. Okay, and then plus 3.34 times x, which is 28, plus 70.421. Okay, so you're going to punch all this in your calculator. All right, let me erase that. Okay, so I'm going to go back to my home screen. negative 0.193, and then 28 squared in parentheses. Okay, plus 3.3, I think it's 341 times 28 in parentheses for our x, plus 70.421. Okay, so you should get 12.657. Okay, and that's in millions of dollars. So it says round to the nearest tenth on your problem. So if we round to the nearest tenth, that's going to be 12.7 million. Let's see. $12.7 million. Oh, yeah. $12.7 million. Okay. Okay, so that's number 2. All right, we'll do one more. Let's do number 3. 3 says the average cost of a new sedan, and it gives you a table. Like we did on the first one, anytime it has years, we don't want to put in like 1998 or whatever. We're going to use numbers to represent that. So the very first one is going to be 1, and then anything after that, it'll keep going. So like it says in part A on your paper, use x equals 1 for 1991, x equals 2 for 1992, and it's going to keep going from there. So it's almost like your 0 would be 1990. Okay, because 1 is 1991, 2 is 1992, stuff like that. All right, so let's go to the calculator. We want to go to Stat, Edit, and we want to clear these lists. So go up to L1 and L2, press Clear and Enter. Clear, Enter. And we're going to put in our table. Okay, so 1991, like we said, is year 1. So 1, 1994 would be 4, 1997 is 7, 2000 is 10 years later, 2003 is 13. Okay, and then I'm going to put in my value in the list too. So 12,800, 15,500, 19,200, 24,300, and 30,100. Okay, like I said, this is the point where you really need to double check and make sure your table matches the table on your paper. Okay. Once you have that all checked and ready to go, we're going to find the quadratic regression. Okay, so we're going to press Stat, right arrow to Calc. Quadratic regression is number 5, and you want to press Enter until it gives you your equation. Okay, so it has your A, B, and C. Okay, so I'm going to write that equation on part A. Y equals, our A is 60.317 x squared. Okay, our B is 602.222 x, so plus 602.222 x. And the Y is 12,123.17, and we'll round that up to 5. Okay, so plus 12,123, and I forgot, 175. Okay, so that's part A. Part B, using this model, estimate during which year the average cost of the four-door sedan reached $37,000. Okay, so you have to figure out, are we plugging this in for X or are we plugging it in for Y? Okay, so part B, if we're talking about $37,000, okay, look at your table. Is that gonna go in the X column or the Y column? Okay, and the money is in the Y column. So we're gonna try to find when Y is $37,000. Okay, and the easiest way to do this is just let the calculator tell you. Okay, we're gonna go to Y equals. We know what our equation is now, right? Okay, so let's see, we have 60.317 x squared plus 602.222 x plus 12,123.175. Okay. Once you have your equation in Y equals, we're going to go to our table and we're going to figure out what year it finally hits that $37,000. Okay. So press second graph. We're going to go to our table, and you can look at your table right now, and it's going up. Like the more you go down, it increases, and we're trying to get to 37,000. So arrow down, keep going until you see that it hits 37,000. And mine finally hits it when X is 16. Okay, when X is 16, I get $37,200. Now, this doesn't mean that it's going to be in the year 16, that's $37,000. So you have to look back at your table and know kind of what we started from. Okay, so remember 1991 was X equals 1. 1992 is X equals 2. We started out at the year 1990. Okay, so we're going to take 1990 and add 16. Okay, and you get, what, 2006? Okay, so in the year 2006, it finally reaches 37,000. Okay, now I want to take the rest of this time to go over one of the problems from your worksheet today. It's a little bit different from the notes just because you're going to have some linear regression models and you're going to have some quadratic, and you need to be able to tell when you're going to use linear and when you're going to use quadratic. So we need to go over that. So if you don't have your worksheet with you, go ahead and pause the video, get the worksheets passed out, and then press play when you're ready to start the example on the worksheet. All right, so on your worksheet, you're going to do the front side only, okay? So you only have 5 problems to do. It needs to be turned in by the end of class, just because most of you guys don't have like a graphing calculator to take home and punch in all this data, and it's extremely difficult to do it on your own. So you're going to turn this in at the end of class, so I'll be able to see like how much you get done and if you're just playing around. Okay, you've got to work. You can talk while you work, you can work in partners, but you need to be working. A lot of it's just punching in the calculator. Okay, so let's look at number 4. I'm going to go over how to do these, how to tell whether it's linear or quadratic. Okay, so on number 4, we're going to put in our table